You deployed your app, it was running, now Kubectl says CrashLoopBackOff. What happened? To debug anything in Kubernetes, you need to understand what a pod goes through from the moment you apply a manifest to the moment it dies. This is pod lifecycle, 5 phases, 3 container states, 1 restart policy that controls everything. Let's go. A pod's phase is the highest level summary of its life cycle. There are exactly 5 values. Pending, the pod has been accepted by the cluster, but it's not running yet. It's waiting to be scheduled, or the container image is still downloading. Running, the pod is bound to a node. All containers have been created. At least one is still running, starting, or restarting. Succeeded, all containers have terminated with exit code 0. They will not be restarted. This is the happy ending for batch jobs. Failed, all containers have terminated. At least one exited with a non-zero code or was killed by the system. Unknown, the phase can't be determined, usually because the node has lost contact with the control plane. One critical note, status is not phase. When Kubectl shows CrashLoopBackOff or terminating in the status column, that's a display field. The actual phase is stored in pod, status, phase. It's one of these 5 values only. The pod has a phase, but each container inside it has its own state, and that's where the detail lies. Waiting, the container hasn't started yet. It's pulling an image, waiting on a secret, or blocked by an init container. Running, the container is executing, the post-start hook has finished, the main process is alive. Terminated, the container finished, either successfully or with an error. You get a reason, an exit code, and timestamps. Now, what happens when a container fails? Kubernetes uses the restart policy. There are 3 values, always, OnFailure, and never. The default is always. Always restart no matter what, exit 0 or non-zero. Use this for long-running services. OnFailure, only restart on a non-zero exit. Use this for jobs that should retry OnFailure but stop when they succeed. Never, don't restart. The container runs once and stays dead. When restarts keep happening, the kubelet applies exponential backoff, 10 seconds, 20, 40, up to 5 minutes between attempts. That's CrashLoopBackOff, not a phase, the backoff mechanism in action. Beyond phases, Kubernetes tracks pod conditions, Boolean flags that describe specific aspects of the pod state. The 4 built-in conditions, PodScheduled, has the pod been assigned to a node. Initialized, have all init containers completed. ContainersReady, are all containers ready, and ready is the pod ready to receive traffic. Each condition has a status of true, false, or unknown. The ready condition is what services use to route traffic. If it's false, the pod is excluded from load balancing, even if it's running. You can also define readiness gates, custom conditions your application must set before Kubernetes marks the pod as ready. This gives you control. Your app needs a warm-up period, or an external system must confirm readiness before traffic arrives. Readiness gates are the escape hatch when built-in conditions aren't enough. Let's pull it together. A pod moves through 5 phases: pending, running, succeeded, failed, unknown. Each container has 3 states: waiting, running, terminated. The restart policy, always, OnFailure, or never, controls what happens after failure. CrashLoopBackOff is exponential backoff, not a phase. The ready condition controls whether a pod receives traffic. Next up, resource requests and limits. How you tell Kubernetes exactly how much CPU and memory your pod needs, and what happens when it asks for too much. Run the docs, Kubernetes, pod lifecycle.